final section. It could turn out to be our longest, but hey ho. Right, okay. We did have to do a bit of factorising in paper 1. There is a chance we might not have to factorise anything in paper 2. But there are 3 or 4 varieties of factorised question that I just want to tick the boxes of, right? A couple here at the bottom that have come up a couple of times in the last couple of years that I probably haven't mentioned so much. So I will mention them in school, and then they're here on this video as well. Okay? Factorising. Okay. The top one, you'd be like, right, factorising means put into brackets, okay? And the only obvious one here, I think, is this. I say obvious, not easy, it's very hard, but it's obvious what you need to do, I think, okay? Here, you'd be thinking, can I take a 2 or a 4 out of there? But that's odd, and it's going to be hard. There's no number that can come out of those, because I was thinking, right, it would be a single bracket, right? But there's 3 types of factorising, okay? There's single bracket, there's quadratics, and then there's a third weird one called the difference of 2 squares. Okay, the difference of 2 squares. Now, this is what this one is. Okay, it's something squared, take away potentially something squared. I don't even know what that squared is for a moment, okay? The 4 is 2 squared, and the m squared is m squared. So what is being squared to make 4m squared is 2m. 2m times 2m is 4m squared, okay? So that's a square. That thing is something squared. The difference means take away, which is exactly what I've got there. And if you square root that, he says, let me actually do it because I wasn't sure myself. It's 17. So I use my calculator for that. So that is 17 squared, right? So this is the difference of 2 squares, right? And it's whatever is being squared to make the first thing, add whatever is being squared to make the second thing in the first bracket. And then in the second bracket is whatever is being squared to make the first thing, take away, right? So the actual formula is this. If I've got something squared here, take away something squared here, then the first bracket, it equals a plus b, a minus b. Now let's do another one really quickly there. So if an easier one, if I had x squared minus 9, that would be nicer, wouldn't it? In the first thing, x is being squared. In the second thing, 3 is being squared. So it would be x plus 3, x minus 3. Okay? It's just as a second example of part B there. Right. Again, there's been a lot of algebraic fractions already gone, okay? But if you get asked to simplify a fraction like this, it generally means factorize, okay? The bottom one here isn't the difference of 2 squares. Well, first of all, it's an add, and then that's not a square number. 35 certainly is a square number, so it's not one of those. So that's just a single bracket. So the bottom, could take 5 out to leave myself 2x plus 7. The top is one of those quadratics that's got a number at the start. Now, we haven't had to do one of those just yet. Okay, in paper 1, we had a quadratic without a number at the start. So I would say, all right, we're going to have 2x, all right. We're looking for 2 numbers that will times to make the end, but the end has to times by 2. It has to times with what's at the start. So we're times it to make minus 14, and adding or taking away to make the number in the middle, which is plus 5. So I'm going for 2 times 7, and to make plus 5, 7 take away 2, plus 7. This bracket isn't divisible by anything, but the second one is divisible by 2, right? Leaving me 2x plus 7, x minus 1, right? Divided by this thing, which I factorised to be 5, 2x plus 7, and that's where you think this is gold dust. I've got this right because there's a bracket in my top factorising that I've also found in my bottom one. So actually my final answer, I only need the second bracket there divided by 5. The 2x plus 7 is gone. Okay, so that's another type. So that covers you 3 types, right? A single bracket, a quadratic, and a difference of 2 squares. Okay, now these are nuts. They are stupid. They are crazy. But they've happened twice in the last couple of years. So we're going to do them. Okay. Here, it's not a difference of 2 squares because that's c cubed. So it's not squared. And that's c, the d is squared, but the c isn't. So it's not a difference of 2 squares. So all I can do here, and all to get 1 mark, is I would take a c outside. If I take a c away from c cubed, I'm left with c squared. Right? If I take the c out of there, I'm left with minus d squared. And a lot of people last year, when this happened, my set 1 just came out going, I did that. And I was like, that's great, that's 1 mark, because that's what I would have done, single bracket, right? Could you have spotted, though, that what is left inside the bracket is a difference of 2 squares? I'm not sure I would have. So actually, that is c being squared, and that is d being squared. So I can rewrite that as a double bracket, c plus d, c minus d, and then that is fully factorized. Because I factorized it into a single bracket, then I've taken what's in the single bracket and factorized it again, and there's nothing else I can factorize. There's nothing else I can do there. So that's one type, when you single bracket, but what's left in the bracket is a difference of 2 squares. Yikes. This one, again, just blows my mind, but okay. Right. It's 5 this squared plus 3 this. Right? If we get one of these to factorize, I'm going to let this, I'm just going to call this bracket A. So I'm going to let A, or whatever you're going to be confused now because I'm using different letters. It doesn't matter what, right? But what I'm trying to say is you could call it X if you want. But instead of E minus 1, because it's the same bracket, I'm going to write it as 5. Call it elephant if you want. A squared plus 3A. So I'm just writing A instead of the bracket, but right, that is what I would factorize. Okay, we would take the A out, and we'd be left with 5A plus 3. Okay, I think this is right. Anyway. It's good that I don't really know what's going on, isn't it? Okay, now, so for me, guys, we now can put that back in. So we'll put E minus 1 instead of A. Then we'll open the bracket and we'll put 5 E minus 1 plus 3. That's it. That's it. It's horrible, but that's it. Right, which is why it's only 2 marks. Like if you came out and if you had that and you came out and said I haven't done any of it, I wouldn't. You know, I don't think it would be a deal breaker because I just think it's one of those that people all around Wales would struggle with. But that's all the different type of factorizing things that could happen if you get one. Okay, right. I know you will get a quadratic formula. You absolutely will, right? You'll need to get it from the front. It's x equals minus b plus or minus b squared minus 4ac. Right, that's all in. That's square rooted divided by 2a. You need the quadratic that you get to look, though, like something x squared, something x, something number. You need it to equal 0, right? In order, and then you can say what a and b and c is. So I've kind of started this one for us, okay? The clue to using the quadratic formula, though, is that you are solving something that appears to be a quadratic when we expand these brackets, and we're wanting answers to decimal places. Again, suggests that we need to use this quadratic formula, okay? So I have expanded the double brackets. Check, you can do that. I've put the equal 7 on the end, but I don't want it equal to 7. I want it equal to 0 if this is a quadratic. So I need the plus 7 to come over as minus 7. If I take the minus 7 away from 55, and also I take the 22x away from the 15x here, so I simplify it all, here's the quadratic I end up with, equal to 0. okay? A is the number there, B is the number before X, and C is the number at the end. Please, please, please do not forget these minuses. So I've written what A, B, and C are here. Right, guys, I think I will do this one. Okay, and then you can do this one. There's a lot of work in that one now. Okay, X equals minus B. But B is minus 7. Don't just write minus 7. It's minus 7. Plus or minus the square root of B squared. Minus 4AC divided by, be really neat, okay, 2A. Now, different teachers will tell you different things. You can work out this bit inside there or whatever. Or if you're comfortable with using your calculator, right, you can go straight to your answers here. X equals, right, or X equals. The first answer comes from putting into your calculator minus 7 plus this divided by 2 times 6. The second answer comes from repeating the calculation but putting the minus into your calculator instead of the plus. So there's where your two answers come from. And do not lose marks for them not rounding your answers as they've asked you to. Both answers to 2 decimal places. One could well be negative, one positive, but they could be very small, like 0 point something, don't know. Check them, okay? Same here, this has been nicer because it doesn't say solve, it says use the quadratic formula to solve, right? A lot more work to do here, mind. Got to square these brackets, okay? All right, well, I'll do that for you. It's 9x squared. It's minus 6x plus 4, right? Equals, and then I'll use FOIL on this bracket as well, x squared plus 1x plus 2x plus 2. Right, oh goodness me. Right, well, I've got lots of quadratic-y things this side and lots this side, but what do I need it equal to? 0. Everything here needs to come over. Take the x squared away from the 9x squared. Minus 6x minus 6x is minus 12x. If I then take away this 1x and take away this 2x, I'm taking away another 3x from the minus 12, so I'll be down to minus 15. I've got a number 4. If I take 2 away from it, it goes down to 2. Think before I fill these in. What's A, what's B, what's C? Okay. A is 8. B is not 15. It's minus 15. Don't get it wrong. Don't get that wrong. C is 2. Copy the formula from the front and then painfully, slowly write everything in. Minus B. Minus B. B is going in there, but B is minus 15. That happens so often that it's minus minus. Plus minus square root of B squared minus 15 squared. Minus 4 A C. C is positive this time, okay, different. All divided by 2 A, and then X equals into your calculator with a plus to get your first answer, and into your calculator with a minus to get your second answer. But make sure, do it twice to make sure you get the same answer twice. That you put in every minus, every bracket in the right place, okay? And again, 2 decimal places for both your answers. Use the word or. Okay. We didn't have to do a show one in paper 1, so it might come here in the quadratic formula one, right? I don't like these. Don't like these at all, okay? But part B is the solve. But in this paper, solving a quadratic is with the quadratic formula and will be to decimal places, okay? In paper 1, this question would have been factorising, but in paper 2, it's using the quadratic formula. Even if it doesn't say it, solve this quadratic, 1 decimal place, quadratic formula. A is 2, B is 3, C is minus 50. Stick them in. get two answers, right? The show that bit is always harder, right? If this one's, then this one's horrible, okay? The area of a trapezium, which is what this is talking about, is given in the front of the book, right? It's half A plus B times H, right? It's hard, just horrible. So it's half A, which is the bottom, plus B, which is the top, and then I need to, I don't know why I put those in brackets actually, but okay. Then I need to times that by H. But I'm told that the area is equal to 25. It's another one of those where I can write equals. That apparently is going to look like that in a minute. Who knows, right? Okay, so first of all, the add in bit. We're not timing, we're actually adding these together. So we've got half 2x plus 3 times x equals 25, and I'm looking at where does that 50 come from in the answer there. So I think it's because the opposite of halving is doubling. So at that point, I think I'll expand my bracket. So 2x times x is that, and 3 times x is that, and take the half over, and the opposite of times in by half is to divide by half, but you end up doubling that to 50. Then we need our quadratic equal to 0. The plus 50 will come over as minus 50, and you've got 2x squared plus 3x minus 50. I hope you switched off in that, because like these bits are nasty. Just get the solve bits right, and in this case, in paper 2, it'll be with a quadratic form that it'll ask you to give answers to decimal places, which basically means don't factorize. Okay, yeah, let's keep going. I don't know if I want to do 4 parts, but I might have to. Okay. Sine and cosine rule. So again, these are given to you, right? So we're now at the back of the paper, and we're now looking at triangles that are not right angle triangles. So we're not using Pythag, trig, base times height divided by 2. We're using the grown-up versions of these, which are in the front of the book. Okay. Right. We have to find the area of the shaded region. We are told that DE, we should write these on as 8, and that EC equals 9. In this, we know this triplet. Right? The triplet allows us to do two things. Either to work out the area of the triangle, which might be useful to us, or to work out the length of the other side using the cosine rule. Okay, I'm going to need the area of the square, and I'm going to need the area of the triangle. So I'm going to actually start weirdly. I'm going to do this in a weird order. I'm going to start with the area of the triangle, which is half AB, copied from the front, sine C. So the angle needs to be big C, and little c will be done here. So the sides become little a and little b. So it's half 8, 9 sine 75 into your calculator, get an answer. Okay? In order to work out the area of the square, it's length times width, but because it's a square, they're the same, but I don't know the lengths. So now I'm going to use the same triplet, but to work out how long the square is. That is the cosine rule, where this side becomes little a, this side, the angle becomes capital A, and these two sides become B and C, and it is that A squared, copied from the front of the book, equals B squared plus C squared minus 2BC cos capital A. B is 8, C is 9, minus 2B, C cos A. Whack it in your calculator, get an answer. Because that's A squared equals that answer, then don't forget to square root that answer to find out what A is. I'm going to make this up. Let's pretend A is 9. right? A is 9, it probably isn't, but it's not, it's going to be bigger than 9. Let's say A is 10, right? Then the area of the square, right, would be 10 times 10, right? So the shaded area is equal to the area of the square, which is length times width, take away the area of the triangle, which I've worked out here, okay, and that's your answer there. I got that same triplet, look, it's nice when I see that, right? Without even reading this, I'm kind of going, right, I can get the area of this, no problem if I need it. The other thing I can work out here is this, with that triplet, that's two things, right? I need to do both above. But if I work out this side here with that triplet, maybe I've then got a triplet here. And again, I could work out this if I wanted to, or I could work out the area then of this triangle. Those triplets are quite useful. There's two things we can do with them. The question says, calculate the area, or this is an area question, of the quadrilateral ABCD. In other words, I need the area of the whole thing. So I need the area of this triangle and the area of this triangle. So there's a lot of work to do here. We can start with the area of this triangle, which is half A, B, sine C. So we'd call them A, B, and that would be capital C, right? That would get me the area of that one. This one is half A, 9.7, B, don't know it for a minute, sine 48. So we just, right? Think to yourself, how am I getting that length so that I can use it there, right? And I'm going to use the cosine rule, again using this triplet. So again using this triplet, but call this, I redraw it, right, and you can do this, call this little a now. So 42 becomes big A, and then these are B and C. I'm using these with A squared equals B squared plus C squared minus 2AB, sorry, 2BC, dear me, it is late at night, cos capital A, right? Okay, leave that to you. Now we're probably at the sine rules, okay? So cosine rules are about triplets. The sine rule is about complete and incomplete pairs, right? Here, I have a complete pair. I have picked this one as a horrible thing though, right? The hardest, the stupidest one I could find. I'm stopping this video after these next two questions, okay? Right, the area of triangle ABD is 16.2, right? In other words, that is the answer. To get that answer, I would have needed this triplet to get that. So, half A, B, which I don't know that side, just put B for now, sine C equals the area. So they've given me the area and I've got to work backwards to get a missing side, right? Nasty, right? Into my calculator though, I can put all of this, and I'm just going to ignore the B a minute, okay? So I'm going to do that. So I'm going to put in half 7.3 times sine 42 equals, okay, so I get 2.44, but don't forget I didn't do anything with, so it's B equals 16.2. So if I divide 16.2 by 2.44, then it'll tell me what B is. 16.2 divided by 2.44, and it is 6.6 centimeters. Okay. It wants the size of this angle BCD. I now know this side. So what I now have here is an incomplete pair to go with my complete pair. So incomplete and complete pairs, that's the sine rule. I'm trying to find an angle, so I'm going to put the angles on top. So I'm going to put sine A over 6.6 equals, and then for my complete pair, sine 28 over 3.6. So if you're using the incomplete pair to find an angle, put the angles on top. If this was using the sine rule, incomplete pair to find a side, we put the sides on top. The opposite of divide by 6.6 is to times by 6.6. So I'm left with sine A equals, my apologies, sine 28 divided by 3.6 times 6.6. I've written times, I haven't written times. Sorry. Again, I get 0.8, and I'm not going to round this because it's not my final answer, so I'm going to give you quite a few decimal places here, maybe 3 or 4, okay? Right, that's what sine A is. Anytime we want to find an angle, we're going to be, like we said in trig, so Katoa stuff, in the right angles, we're going to be sine -1 in that, right? Let's do it. Shift sine 0.8932. So the answer to that is 63.3. Okay, we've covered most of the rules here. We've done quite a lot on area, right? We've done cosine rule, right, with the triplet to find a missing side. I've done a sine rule now, a complete pair and an incomplete pair, okay? And then there's this monster, the one I hate. The cosine rule to find an angle. It's gross, right? I want to find this angle. This angle becomes big A, so this is little a, this is B, and this is C. The cosine rule, it's when you know all three sides to find an angle. Okay, if you know all three sides, it's unusual. So it's not triplet and it's not complete and incomplete pairs. Let's just hope yours are either a triplet or a complete and incomplete pair. But if you get this set up, we're just going to stick these numbers in here. Right? Little a, we actually know, which is bad, we know the answer, equals B. It doesn't matter which one's B and which one's C. It matters which one's A. That's important. B and C, don't matter. Plus C squared minus 2B C cos, and that's what I don't know. Right. That can go over as a minus. That can go over as a minus, okay? And this, whatever this is, when I work this bit out, right, is then timesing that cos A. So I will then have to divide by this. Okay, so hopefully this makes sense. Now, you could have done some of this by now. It's that minus that when it's gone over, minus that when it's gone over, divided by minus, and again, you may or may not have already worked that out, but that's the awkward bit, that minus 2bc, because the minus 2bc is times in cos A, the opposite of times in minus 2bc, the opposite of that times in that is to divide by that. That's the hard bit. And again, the answer to this is probably going to be 0 point something. You'll then have to cos -1 that to get A. I am going to do a fourth video, I'm so sorry, right, because I need to get a cup of tea or something to keep me going, yeah, okay? See you for the last bit.